Okay, so let's uh, play with .NET, and let me, as usual, get these open in another window so I can refer to it more easily. Right, there we go. All right. So I got these with this Windows machine here, and we have to download some samples. Let me get the link and download them here in Firefox. All right. There's my samples, and they're zip files, so I right-click, extract all, extract, and that makes a folder that includes a couple of programs to run. All right. Now, I just want to run the challenge1 file and approve running it anyway. Microsoft Defender doesn't like it. Okay, now it's going to tell me I need Windows 3. .NET 3.5, which is rude. Let's see if I can do it here. This thing often fails, but we'll see. Um, this is, by the way, the same thing is true of Java, as you probably know. If you try to run a Java program, most of the time it tells you you need a different version of Java, and people end up with 4 and 5 and 6 versions of Java installed in their machine, and it gets very confusing. Microsoft has recreated that situation with .NET. And some version of .NET is included with Windows 11, but it doesn't seem to maintain compatibility from version to version. You often need an old version of .NET. So they've created kind of a smaller version of the same mess that Python apps have in Linux, where you need old versions of libraries and stuff. We'll see if this works. In my experience, this often fails, and you have to hunt for .NET separately and put it on. It might work in Windows 11. It's friendlier than Linux, I'll say, because Linux will just crash with baffling error messages. And here it gives you a link to get the version you need, which, if it works, it's a whole lot friendlier than what Linux does. But it often doesn't work. Now, I could pause recording. I'm going to give it another minute before I try that because I'm a little skeptical of Zoom working correctly with pausing and restarting. But this is quite common that Microsoft downloads fail, and it is Patch Tuesday, so the servers are probably more likely overloaded today than other days. All right, I'm going to try using the Zoom pause feature and see if it works, because this looks like it's going to take a long time. Okay, so I completed the .NET install, restarted the machine. It went through a slow updating Windows menu, and I got back in. And now it can run this .NET program. It does complain, but when you tell it to run anyway, it pops it up, and here's what you see, Bob Ross, and you can decode it here, and it turns into garbage. So there's an encoded thing, but you somehow have to figure out how to decode it. That's the point of this. All right, let me get to my all right, so we can use CFF Explorer to find out what kind of program this is. More options, open with CFF Explorer. And looks like Windows is going to complain about CFF Explorer too. But anyway, here we are. And here you can see that this is a portable executable 32-bit .NET assembly. So that's what it is. And to see what that is, you can use ILSpy, which is a really nice program. ILSpy lets you see what .NET is. All right. And I think it runs a little slow because I think it's running through an ARM to Intel translator. All right. So this is ILSpy. And now I can open File open, challenge one, which is downloads, and this folder and that folder and challenge one. All right. And so it shows you a tree structured directory of objects, some of which are part of .NET itself. And down here's the challenge. And this is exactly, if you remember, we did this with Android apps in JADX GUI to show the structure of a Java app. And like I say, it's very, very much the same. You have a tree structured directory here. So what we want to do is go down to resources, and then let me shrink this down and move over to my instructions to scroll them. Resources, and then button decode. There's a decoding button in the form 1, which is in the XXX container. There's form 1, and there is a button decode, click object. And that has code here. And this is where you can learn what .NET is. The raw .NET is IL, called intermediate language, and it looks like assembly code, but what it is assembly code for the .NET runtime, which is exactly analogous to Java bytecode for the Java virtual machine. And that's the whole point, is to be platform independent. Although I don't know why a Windows product bothers to be platform independent, but that's the idea. So it's compiled. It's partially compiled. It's compiled down to this stuff, which looks like assembly code, but it's not. It has to be run in a sort of virtual machine, which is the .NET runtime. And it just has these little commands that load registers and move things around just like any other assembly code, but it's closely related to source code, just like Java, and you can choose to see it in C#. It will decompile it and write the C#. And now you can see what the decoding is. It's real simple. It takes each byte in the secret, it shifts it to the right 4 bits, and then does an OR, a logical OR, with it shifted to the left 4 bits, ampersand F0. So it's taking the nibbles within the byte and flipping them, interchanging them. A simple transformation, and then doing an XOR with 66. So that's the simple obfuscation technique to make it hard to extract the key. So now I know the algorithm is that, and we can get the secret data. To get there, I have to go into resources, and then the secret data is here. There, data secret encode, and it's a file, and I can save this file. So I'm going to save it in here with the name .secret. All right. And now I can decode it with Python. And I don't think I'll bother doing it. Let me just point to it. Now, this machine has Python 2 installed. It comes with one of the debuggers that's installed. And here's the code that just does it. You just do the same thing. You do the same shift it to the right 4, or shift it to the left 4, ampersanding with F0, and then XOR with 29, which I think is the 32 plus 9, that's 41. I don't know why it's not 66. Let's take a look at this code again. Oh, it was, that's a little screwy. Let me see if the 66 is what I saw here in my exam. It is 66. Show X66. So that part a little bit confuses me. I XORed it with 29 to get in there, to get the flag. And perhaps that was not for the challenge. Anyway, you may have to adjust that. I'm not sure, but I'm not going to bother typing in this code to do it in live demo here. Anyway, that's the point. This is one way. I mentioned before, sometimes you find malware and you find the decryptor and you can just run it and put it in a breakpoint. Another way, of course, is to read the code and rewrite it in the language under your control, like Python, which is pretty easy here. And just like Android apps, the main message here is you have source code with .NET apps, and people should understand that. It makes it much easier to reverse engineer. So that's the first one I wanted to show you. And now let's go on to the next one, which is ED330. here, where we're going to make a .NET app, which is pretty simple. Um, all right, so we have to have Visual Studio, which we have, although I may need to install more to have the .NET. Let me try that. Um, I should have the Visual Studio installer on here. Here's the Visual Studio installer. And I may need to add the .NET runtime environment here. Let's see what happens. Now I'm thinking about it. I think I don't have it. Update available. Well, I don't care about that. I want it installed. How about available? Uh, well, modify. That's what I want. Okay. And here's .NET desktop development. That's what I want. Okay. And so it is going to be another 5 gigs of stuff to download and install. Okay. So it's good that I found the pause button. Let me pause this recording again. Another slow process here. Occurs to me, I missed some of the fun stuff in the previous one. Let me go back to that for a minute. See, after you did this one, where you just decoded that thing with the picture of Bob Ross, there were some others. There's a second file here that's similar. And then there was a thing called Meme Cat Battle Station, which is fun. Let's see if this is going to work if I download it. Copy link address. Okay. And I got these from the Flare On contest. They have a CTF every year for malware analysis, and a lot of it is very difficult, but I take the easy ones and add them to my course when I can figure them out. And this one is pretty cute. Malicious file, uh, run anyway. All right. I don't know why they think it's malicious. That's pretty ridiculous. It's just a graphical game. There, the cat is coming. And in order to shoot the cat down, you have to put it the right arming code. And if you put in the wrong thing and fire, then you don't make it. So all you have to do is find 2 hidden codes to win this game. And if you look at the project instructions, you'll see you can get it by just reading the source code. Just like that game, which was also from Flare On, where you had a teddy bear and you had to play with it and feed it and clean it in a certain pattern to win. And you could figure it out by reading the source code. Here, you can figure this out by reading the source code. You put it in IL Spy and you can find out the code for the fire button. And the next one, you have to like decrypt something. Again, some data to find the right code. So, but you can read the source code. So it's pretty easy to figure out what the right magic words are to win the game. So that's kind of fun. Anyway, and now let's go on to this ED330. I've got Visual Studio installed with the .NET stuff, so I should be able to make a .NET app in Visual Studio. So let's get it going. Visual Studio. All right. And then I want to create a new project. And all right, create a new project. And all languages, all platforms, all project types. And now I want to find a console app that can run in .NET on Windows, Linux, or Mac. So they do regard it as cross-platform, although I've never heard of anybody using .NET on Mac or Linux. But in principle, it can run there, just like Java. Okay, so console app and next, configure your project. The default name is fine. And now it should create an app. Create. All right. Right, it creates a Hello World app, which really has only one line, console, write line, and a comment. So that's pretty nice. So now you can run it here. That will run it in debugging. It'll do the building down here, and then it's showing some kind of error. Oh, there it goes. Build started. Okay, it's moving. Skipping analyzers to speed up the build. Okay. Good, it runs. And here it is, popping up a box. And in that box, it will hopefully write hello world or something pretty soon. There it goes. It printed hello world and then had to press any key to close this window. So it ran. It successfully made it. I can press enter here to close that window. All right. So now I can do some string manipulations in .NET. So let's get rid of this old code and put in my new code, which is going to be, I wonder if Control Plus will work here to make it bigger. No, nothing that nice. All right. Anyway, so I make a string that's short, and then I just read something from the user and print it out. And what I'm trying to show here is a buffer overflow. I make a short string, then I read data from the user and echo it back. So maybe if I put in long data, I'd get a buffer overflow. So let's run this one. It compiles and runs, and there it is. And it's waiting for input from me. So I put in hello, and it says you said hello. So that's fine. But if I put in a long string like this, it handles it perfectly fine because this is a memory safe language. It doesn't do the foolishness that C would of reserving only enough space for this and not making it bigger when more data comes in. But you can put unsafe code in .NET. So I can replace the code with this. And now I have a class here. Here's a buffer overflow. And this is going to do it. C would have crashed, but C doesn't. This code is going to crash. And that's now you're going to, because it's going to bring in the pointer and then explicitly just add characters to the end of the pointer the way she did. I've written code to crash, but the fact is it's only going to let me compile this if I um, adjust the properties. So from the menu, Project Console 1 Properties, okay, and in here on the Build tab, uh, okay, Build General, Allow Unsafe Code is somewhere in here. There it is, Allow Unsafe Code. That's it. And now that's it. I don't think I have to click save or anything from here. Now I should be able to run it. And there we go. Compiling, building. All right. And now if I put in long string, it it crashed with an error code. So, it did have a buffer overflow. You can make it if you really, really want to, but it's not something that would happen by accident in .NET. So that's one thing to know. Now, let's make graphical stuff in .NET. File, new project. All right, create a new project. That's right. Windows Form app is what we want. Um, Windows Forms app. And I'm carefully reading it because there are often a lot of similar things. I'm the one that starts with C sharp. Uh, and I want it to say .NET Windows Forms app, a project template for creating a .NET Windows form. C sharp Windows desktop. That's Visual Basic. Uh, let's see if I can make any. Let's try Windows. See if I can make it simpler. These things are confusing. I want Windows Forms app, but I want to get the right Windows Forms app. This looks pretty good. C Sharp, Windows Desktop. Yeah, that's the one. Okay, good. You have to somehow pick the right one out of those many options. Okay, then next and create. Good. And like before, it'll create a default app for me. Okay, so it creates a sort of a blank screen to work with. And now you have to view toolbox. And now you drag things in from the toolbox, which are here. So I have to drag in a label control, which is in the common controls. Okay, so I want a label. All right. And here's the toolbox. Okay. There's probably some way to detach the toolbox. Uh, there. Okay. Now I've dragged in a label. Now I want to add type password and press enter to put it on the label. I wonder if it'll take it now. Um, double click. Nope. Okay. Double click took me somewhere bad. I want to be here. Okay. There's some way to actually type in there. The other way is to go down here and adjust the text. Um, Password, enter. There. Now my label says password. Now drag a text box in. All right, and put it here. Okay. Drag a button and put it in there. All right. And now I've typed enter to put on the button. And it's still not letting me type directly on that. Oh, it did. Okay, good. So now I have password, a place to put the password, and an enter box. All right. That's all I wanted out of this. Now I have to enter code for the button. So you double click the button, and now you can put in code. And so I have to add this code in the private void. This is how you make a password guessing game, which is what a lot of the games we played here have been. There. If text box equals top secret, you win. Otherwise, she'll fail. And now I think that's it. Now I can just run the form. So it's building it. And if there were going to be errors, it would show up down there. And there it is. It's running. So now if I type in the wrong password and press enter, it says fail. But if I put in the right password and press enter, it says win. So that's all it does, but it works. All right, so now the app has been compiled, and in this lower left window, in the output window, if I can find it, it has saved the app, but it saved it buried deep, and it's hard to find. And I have to stop debugging. That's why. Somewhere there is a stop debugging option. Debug, stop debugging. There. Now I have this window, and in this window, it will tell me where the thing is. Build, maybe I can make this taller there. Somewhere is build one succeeded. Show output from debug. I think I need to show output from build, probably. Yeah, there we are. Here's where it is. See user student source repo. This incredible path is where the app is. So you have to navigate to the exe file that you built. So let me get a Windows Explorer window here and get it so these two things are visible on the screen at the same time. And we can dig into this mess, which is C users, student, source repos, WinForms app, bin debug, .NET 8, WinForms API. Here it is, and there's the exe. So that's the executable, which I can run outside. And if I go into properties, you'll see that it's an application. And if you go to compatibility, it's a Windows on ARM, but it's actually .NET. So anyway, that's how you make a .NET application. And you can see how it's pretty popular. It's easy to handle the GUI and stuff. Looks like using Microsoft Office or other things like it. And there's a little more, another project to check out here about .NET ED331. In this case, we're going to use a product called Reflector, which is a lot like ILSpy. And You have to install a 15-day trial version. So the installer is included in the machine I made, but it isn't all pre-installed. I already installed it. So we're going to examine this app here, copy link address, and we don't need Visual Studio anymore. All we need is Firefox to download this app. All right. And there it is. All right. And let me get my instructions up here. All right. So I think you want to run it first. Yeah, there we do. Let's run it. Oops. There. Run it. All right. And it is a password guessing game like the one we made before. So if I put in the wrong password, it says fail. And I don't know what the right password is. So we're going to find out with Reflector. So if I load .NET Reflector, there it is, .NET Reflector. And all right. Uh, welcome. I don't need that. Show default assembly. I click OK, use the defaults. And now I can open it here. Yeah, File, Open Assembly. And now I go to my downloads, and this is it. And just like the other .NET analyzing program we used, it gives you the tree structure of all kinds of system stuff, and then at the bottom is your Windows Form app. And so you can find the button in there, which is in the Format 5 form derived types. Format 5 should see Form 1. There it is, Form 1, and derived types. And here's a button. Button click object. That's it. And when you click on it, now you see the code. So it is the same thing. The written password is top secret. Now, we can also view this in IL form. What we're seeing now is C#, but we can choose to see it in another language, like you can see it in Visual Basic, or you can see it in intermediate language, which we see here. And what we're going to do is we're going to hack this app and cheat on it just the way we cheated on the other game. So notice the instructions here. You can read this stuff. It loads the string top secret. Here's the instructions. Store location, load location, branch if false. Then you go to either win or fail. So it'll branch to line 27 and fail. But if it doesn't branch, then it'll go. So here it's done some kind of comparison with these commands. And I'm branching on false. So I want to change this to branch true instead of branch false in order to make a game that will win when I put in the wrong password. So to do that, I can find the hexadecimal codes. And for some strange reason, they aren't included in this application. I had to go on Wikipedia to find the hex codes for .NET. But here they are. And so you can find BR false. And this is BR false, an integer 32 target, which I think is what we have. When I looked it up before, my answer was BR false is 2C and BR true is 2D. So let's try. There's probably more BR falses here. Uh, yeah, here's the 2C. An int 8 target is what we have. And a BR true int 8 is a 2D down here, which is less clear here than it was when I looked at this Wikipedia page in the past. It looks like they've made it sort of more complicated. But anyway, the fact is you want to change it from 2C to 2D. And if you look at the instructions here, you can see the pattern of bytes that you need to change is this 0A06 2C to branch somewhere, and then 72 is part of the load string. So you have to find this pattern in a hex editor and change the 2C to a 2D. So you can do it with HXD, a raw hex editor. And so I can load that file here in the hex editor, which is downloads, this one. All right, and now I wonder if I can make the font bigger. I think I can. View, options, view, format. Aha. Uh, Font. There we go. All right, good. Make it somewhat easier to read, especially in the video. And now I just have to search for this pattern 0A062C, which is Control F, and search for hex values 0A, 06, 2C. All right. So I search for it, and here it is. And there's a 72 is the next one. So this is the right one. This is the one I want to change. So I want to change that 2C to a 2D. I just click on it and type over it. It turns red. Now I can save the modified file. File, save as, and I'm going to call it this mod. There. I got to call it nod by accident, but it doesn't matter. Now I've done that, and I can go here and find it. Let's try sorting by name. There, sorting by name. There it is, the modified one. So if I gave you the modified one, and I put in the wrong password, then I win. And if I put in the correct password, top secret, then I fail. So I've reversed the logic of this game to cheat on it, and you can see how easy it was to do. All right. And so there are some flags where you have to and take out for more games and cheat on them just to practice with .NET. So that's the joy of .NET reversing. That's what I wanted to show you. I'm going to stop this video.